Hello everybody. I'm going to start our presentation. First of all, I'll introduce our group members. I'll start with myself, Galib Arhab Adel, and my friend Zhou Lixin, and Yuggen Nagappan, and Mohammed Fareez, and Hanna. Our topic is integration of arc length in rope of suspension bridge, which is divided into four parts. Number one, objectives. Number two, main points. Number three, discussion. Number four, conclusion. I will start with the objectives. What are the objectives? The objective is divided into three parts. We'll start with 15% to easier the calculation for bridge rope construction, and 30% to know the arc length is first approximated using line segments, which generates to remain sum. And finally, 55% to calculate the arc length by a curved bridge rope using definite integral. Here we come to main points. What is the topic about? Integration is a way of building slices to get the whole integral. We can use integration to find areas, volumes, central points, and many useful things. Thus, the process of finding integral is called integration. Moreover, integration is a core operation of calculus that serves as a tool to solve mathematical and physics problems. In four graphs of main points. Number one, in the 7th century, Isaac Newton and Gottfried William were the first to develop the principle of integration. Number two, integration can help in finding areas, volume, central points, and many more. Number three, it is used to improve the infrastructures such as bridge. Number four, integration of arc length can be achieved after derivatives. And here we come to discussion. I will pass this to my friend Hanna.
So thank you to Arhab just now. So today I'm going to continue the presentation with discussion. So in our case study, we are going to know how to calculate the arc length of suspension bridge and also how to derive the formula of arc length by using integration. So how did it occur? So there are three steps that we need to follow in order to get the arc length. So the first one, we need to take the derivative of fx. The second one, write the arc length formula. And the third one, simplify and solve the integral. So now I'm going to show you how the formula of arc length is being derived by using integration. So first of all, we need to find a smooth fx function in order it to be distinguishable and can be derivative. Next, we make a line segment in order to get a formula for vertical distance over interval. So we will get the formula yi equal to fxi minus fx minus 1. Next, by using the Pythagoras theorem, x2 plus y2 equal to c2 is the length of the line segment. It also can be written as x square root 1 plus yi minus x power of 2. Now, by means of the mean value theorem, x power of star base I element of xi minus 1 xi is written such as a way that f prime x power of star base I equal to yi over x. The length of the length of the line segment is then defined by x square root 1 plus f prime x power of star base I power of 2. We next adding the lengths of all the line segment of the line, we get the arc length approximate to n I equal to 1 square root 1 plus f prime x power of star base I power of 2. Moreover, by using the Riemann sum, we consider the limit n approach to infinity. Hence, we can summarize that this finding as integral of PA square root 1 plus f prime x power of 2 dx. So after we get the derivative of a function which can be written as f prime x, we can calculate an exact answer by solving the differential and integral parts. So for the next slide, we are going to see some examples on how it implies in real life on how to calculate the suspension of bridge. Here comes the application in real life, how we want to apply the formula that we have been derived at the previous slide into the real world application. So as the topic, we are going to apply the formula of arc length in order to find arc length in the suspension bridge. Given the problems is metal posts have been installed 6 meters apart across a gauge, so find the length for the hanging bridge that follows the curve given fx equal to 5 cos x divided by 5. So as you can see at the right side, there's a graph. So this curve is called as the catenary forms a hanging cable. So we're going to use a solution of the formula of arc length. So s equal to integral of BO square root 1 plus f prime x power of 2 dx. So why we use integral b 0? Why we put 0 instead of a? So because the curve is symmetrical, so we only take half of it. So we're going to written down in the formula s equal to integral b and 0. So here comes the calculation. So for the first step, we are going to use the formula of arc length. So s equal to integral b0 square root 1 plus f prime bracket x power of 2 dx. We then substitute the sin h bracket x divided by a into the formula, as the derivative of f prime x is sin h bracket x divided by a. So we can see in step 2 the formula is changing as we already substitute the sin h bracket x over a into the formula. So we will get the formula as equal to integral b0 square root 1 plus sin h squared bracket x over a dx. Next, we are going to substitute the cos h squared bracket x divided by a into the formula as 1 plus sin h squared x over a equal to cos squared bracket x over a. So we will get the formula as equal to integral b0 square root plus cos squared bracket x divided by a dx. So we can simplify the formula we can simplify the equation and get s equal to integral b0 cos bracket x divided by a dx. And for the step 5, we are going to calculate the integral, and we need to know that the symmetry is from negative b to positive b. So we are going to substitute the negative 3 to positive 3 into the formula. So in the step 6, we know that a equal to 5 and the negative b to positive b is negative 3 to positive 3. So we are going to substitute into formula. So we get the formula as equal to 25 sin h bracket 3 over 5, and we will get the final answer, which is 6.367 meter. So by the end of the calculation, we can know that the length of the arc length of the suspension bridge is 6.367 meter. So I'm going to pass my presentation to Fareez. Thank you.
Okay, now for the question 1, it wants us to find the length of fx equal to 2 and between x equal to 2 and x equal to 3. As we know, fx equal to 2 is a straight line, so we can see it in the slide. Okay, for the solution, firstly we need to find the f prime x. To find f prime x, we need to differentiate fx equal to 2, so we will get f prime x is equal to 0. Next, by using the equation given in the slide, we can calculate length of fx equal to 2 between x equal to 2 and x equal to 3. So we already find the f prime x, and then we will substitute f prime x in the equation, and then we calculate it. We will get 1. So, and after that, we will integrate 1, so we will get x, and then lastly we substitute the value of 3 and 2 in x, and then we need to minus it, and we will get 1. So the length between the arc length between point 2 and 3 is 1. Okay, for the next slide, Lizin will explain to you about the question 2. Thank you.
Okay, here is the graph tells us some simple information. The axis between 2 and 3. And we can get the integral like fx is just. And then we give out our first equation. It's like here. And just for the fx one. And we can get it simplified like this. And it's very easy to get a more simple answer. And it's like here. And then we will get the final integer. And this is final integer. And here. And the last answer is just square root 2. Yes, square root 2 is our final answer. And thanks everyone. Thanks. My part is finished.
Thank you, Lixin. Now we're going to look at the last part of our maths project, which is the conclusion. To find the arc of length, we should find the derivative of the function followed by the formula. The formula is obtained by using the Pythagorean theorem and mean value theorem. Using integration, the hanging bridge will be balanced in the right amount of force either in tight or loose position. Other applications of using integration are connect two power stations which are very far away from each other, or to find the distance traveled by a rocket in a parabolic path. Thank you. That's all from us. Any question regarding the slide can be emailed through the email given below.